Hey everybody, welcome back to another Hive Jive here, and I am joined as always with Miss Natalie. How are you doing today?
Howdy, howdy. I'm doing fine, thank you. I hope everybody is peachy. How are you
Peachy.
doing,
Oh, I
Doc?
love peaches.
Yes.
They're almost out of season, unfortunately. But anyhow, we are going to just jump straight in today. We have a very special guest. And to do this, we're going to have to go across the pond. We're going to be going over to the southeast of London. Southeast of England, just outside of London, technically, so that we can speak to Mr. Steve Riley, who is the current chair and education coordinator for the Westerham Beekeepers Association over there. And Steve, welcome to the Hive Jive.
Thanks for having me. Thank you.
You are welcome, sir. It is our pleasure and honor to be able
Yeah.
to have you on here. It's not that often that we get to talk to somebody from overseas in your area, which is going to be really fun to kind of see how things line up with us versus what you guys have to go through. And also, we're going to be talking very heavily about your book that you wrote earlier this year, which is The Honeybee Solution to Varroa. And that is something that all of our listeners will be able to take into account, especially those of you down in Australia where this is a new thing that is coming about and everybody's pretty freaked out. Here's a good example of something that you can get your hands on and do some learning ahead of time and have some tools and some ideas on how to possibly better mitigate the situation once it reaches your area. So no no easy task there, but we'll see what we can accomplish with it.
And then for those of you who haven't seen it and you are on the video, I think the Patreons do see that. It's written backwards, but it's an awesome book and it's a very straightforward to read. It's not overly, overwhelming, and it's just very informative with a whole bunch of things. And it all relies on bee biology and Varroa biology. It's an amazing tool if you want to raise your bees naturally and just kind of leverage your understanding of both to be successful doing so.
It's only written backwards if you don't have Zoom to mirror your screen. For
Oh,
everybody else, it's written frontwards.
yeah. I mean, the book itself is written forward. You won't have to worry about reading it.
Well, Steve, so kind of what got you started into this whole aspect of coming up with this book? Like, you're involved in the association. I know that this is a big thing over there. What inspired you to go through and put this down on paper and be able to share that for everybody else?
Yeah, if I could just track back a little bit,
Yeah.
we were interested in trying to understand why bees were starting to survive Roa, and we thought, well, if they're doing this, this must be something that we can learn about. So we started following every bit of research was available, and there's so much open access research out there now. I mean, huge credit to all the institutions and researchers for that. Particularly the early work that was done at the USDA was just fantastic, and then we also had good access to all the European research as well, and then we met up and with a chap who was working hard on the whole subject for most of his career, Dr. Ralph Buchler in Germany, who showed us a way to transition off miticide treatments without much risk, and that seemed to work. And then we realized that actually, if we were going to make a success of this, we needed to stop doing any Varroa reduction at all, and we needed to find those traits which we could follow up on. And so we started this project. We've just finished our seventh season, and we started presenting on it, showing different clubs what we were doing around the UK, and a few beekeepers said, well, where's all this written down? And he said, well, it's not. Well, why don't you? And I thought, okay. So we did a few articles for some of our bee press, and then we were approached by Northern Bee Books, who said, well, why don't you put this, down in a book? So and that was it really. That was the start of a lot of hard work a couple of winters ago, which the first winter we got interrupted by trying to put together a website with Professor Stephen Martin and two or three other beekeepers in different parts of the UK who already had Varroa resistant bees, and which we launched about a year and a half ago in the spring, called varroaresistant.uk. And on there, there's all the relevant research and illustrations of the traits. And so we put a lot of effort into that. So once that had been launched, we then had the opportunity, or I had the opportunity last winter just to try and put the book to bed, and which is what we managed to do. And then so we launched it in the spring. So there was a little bit of, well, quite a lot of demand, I think, out there in the UK just to move off miticide treatments. And at the same time, there was an eagle-eyed publisher who saw an opportunity. And I think I'm right in saying it's the first book of its type. And hopefully there'll be lots more as well. Hopefully it'll inspire others. And it's written from a beekeeper's perspective for beekeepers, which I think was Nathalie's point really, that it's written for everyone, and the traits are actually incredibly easy to observe, and then pretty straightforward to select for. So you don't need to be into artificial insemination. You don't need to be commercial. You can be a hobbyist beekeeper and move forward with it. So that was a little bit of background, John, to that.
Yeah, and so the aspect of this with the different behaviors that you can go through and look at, that was one of the things that I pulled out of there, is you draw a distinction between hygienic behavior and Varroa resistance, because we hear a lot of talk about, oh, you need, Varroa sensitive hygienic, but then you also need hygienic bees, and there's different ways to look for the hygienic traits, and you kind of go through and make it a lot more easier to understand about what those traits are and how to specifically identify them. So can you kind of give us an overview of that aspect? I mean, I know that's a very in-depth meat and potatoes concept of it, and we can go more in depth on that later, but just for the general idea of it, what is the difference between those two aspects?
Yeah, well, I mean, the first point is, which you've touched on, is it is another form of hygienic behavior. So hygienic behavior is a good thing, and it's that bees looking after their own problems as they go. And we know they can do this. We know that they uncap cells for chalk brood. We know they uncap for wax moth and those straight lines that you see across the brood. We also know they can handle American foul brood. And we also see them uncapping for sac brood virus here as well. So this is an extension of something which they naturally do. So and it's what they've learned to do, or some bees perhaps had the genetic traits already, was to locate Varroa offspring and or bees which have got deformed wing virus. So and then those cells are identified, they're uncapped, which is the sort of the investigation part of the process. And if there's a problem with the pupae, then the pupae is hauled out. And in taking that pupae out, it will stop any Varroa which are in there from reproducing. The mother mite will usually escape, but all the offspring will die. And the key part of this is that it occurs before the Varroa offspring have been able to mate. So this is the biology part of it, that the son, which is the first egg that gets laid, and then is followed by a series of daughters. The son is going to mate with the daughters. It's not the height of romance, but it's incredibly efficient for the mite family, and the uncapping and the interruption of the Varroa reproduction takes place about 5 or 6 days after the cell has been sealed. And this is 2 or 3 days before the offspring mites are mature enough to mate. So there's no mating, there's no reproduction of that family. All of the offspring will die, all soft-bodied and immature. They all die. And the real crux of this is that the mother mite will only mate 2 or 3 times, and that's all she's capable of doing. And then she becomes infertile. So you're actually producing a large cohort of infertile mother mites through this uncapping and interruption process.
Mm-hmm.
And the work that, again, as a Stephen Martin led bit of research showed that in Varroa-resistant colonies, which are naturally resistant, there was an average of about 45% of foundress mites which were infertile. But in colonies which are susceptible, i.e., don't have this level of hygienic behavior and activities, the average was around about 17%. So,
That's a huge difference. I mean, it really is probably the make or break difference between the two. I think it's amazing that they're the other thing that kind of gets into this is how the way we measure mite infestations and we do mite counts, but we don't take into account if they're fertile or not,
yeah,
right? And there's no way for us to really tell unless we dissect them or just analyze them in a lab, right?
yeah, absolutely. We can't do that, and we shouldn't be expected to. So here's our simple process. So firstly, seeing uncapping at the pink to purple-eyed stage is easy. If you unless you never look inside a hive or never look at brood comb, but anyone who does look inside, then they will see that. And when you see it, often it's a little cluster, which is interesting. We'll come back and talk about that. But they're quite easy to see. They're quite easy to note. And immediately, if you've understood the rest of the process, you'll know what's going to happen next. That the bees will chew out some of those pupae, and in doing so, they'll create that level of infertility in due course. So the other part of the monitoring, which you can do again very easily, and it's we've been a bit fortunate here that after Varroa arrived, everyone bought these open mesh floors. I think you call them screened floors
Yeah,
in the
screen
US.
Bottom
boards.
boards. Mm-hmm.
So we've all got these open mesh floors or screen bottom boards, and a bit of the pupae, which is getting chewed out, just come down and fall through the comb on through the open mesh floor onto this bottom board. So you can see there are chewed out bits of exoskeleton, bits of antennae, bits of head and thorax. And so you know that's the completion of this process that's going out. So that infected pupae is being chewed out and you can see it. So you start to understand it. So when I look at my board, if there's 10 mites on there, I can be pretty certain that roughly half of them are going to be infertile because I've seen the rest of the process. And once you start trusting in the process, you get it straight away. And if you're having low levels of mites because of this, and that has to be the final test, if you've got low level of mites because of this interruption taking place, then you will have low levels of deformed wing virus.
Mm-hmm.
And no more complicated than that, that's the really good thing that this is open for all beekeepers once they've understood that process.
Is there also a part for the immune system and the vitality of the colony to play where I mean, that's kind of my guess anyway. The healthier they are, the less stressed out they are, the higher their immunity is, and the more able they are to sustain a certain level of infestation of viruses. So everything being equal, you would have a better resistance in effect that's not just linked to the number of mites, but also to their vitality, right?
Yeah, yes and no, I think. So we like to think that the sort of the ancillary helpful things that we can do for the bees is to reduce stress. And so we rough up the edges of our brood boxes for propolis. They eat their own honey. They feed and eat. They always have done. If you want to take it away and feed sugar syrup, then you better. You might have a commercial reason for doing that, but it won't be a good healthy reason necessarily. We insulate the hives summer and more so in the winter. So we try to replicate a little bit of what they're used to, and we try not to open them up too often because you're going to change the temperature. We have different temperature differences in the UK compared to you guys. So if they're trying to keep their brood nest at 35 degrees, it makes a difference when you open it up at 16 degrees. So we try not to go in too often once swarming season is finished, and that can help as well. So certainly less stress is helpful. But let's just sort of step back a bit from this. You think about what happened in the Arnott Forest under Tom Seeley. So he's got a sort of real live and well analyzed example there of Varroa arriving, and then there being a massive reduction in honeybees in the forest, and then they repopulated again. And he wasn't there at every step of the stage, but he was able to look at the genetics before and afterwards, and you're able to see that only a few queen lines went forward, so the rest died, the rest perished. Now these bees are living in what most natural beekeepers would say are the best conditions. They're in I know it's much further north than you. They're in the tree cavities. It's well insulated. There's probably a propolis envelope around the brood area. They're not being interrupted by beekeepers in their white jackets. There might be the occasional bear climbing up, but this is a non-stressed environment for them, but they still didn't cope with Varroa. And I think that's the bit that I come back to. And I think that's why all these things that we've talked about there are helpful, but they're actually not the solution. There's a bit about virus tolerance that we don't know enough about yet. And Barbara Locke led some brilliant research on this on the Gotland Island bees in Sweden, where they did this experiment where on Gotland Island, they've got these very resistant bees, and they've also got the managed bees, which need treating to keep alive. And they injected them with amounts of deformed wing virus and acute bee paralysis virus. And what they found each time was that the Varroa resistant bees lived a bit longer than the non-resistant bees. And I thought, well, that's interesting. So they then tried that experiment in different countries. They tried it in Norway, in the Netherlands, and also in France, where they've got populations of resistant bees in the same area as the non-resistant bees. And each case, the resistant bees lived longer. So there's something about virus tolerance which we don't know about, and it's not something I suspect we can ever select for as beekeepers or observe. But it's nice to know it's there, and it's subject to more research in due course, which is pretty tough. All the virus stuff is pretty tough to follow, isn't it? I think anyway. With but I think we'll get a bit more clarity in due course.
The selecting aspect I want to hit on real quick, because again, that is something that a lot of beekeepers out there are trying to do, especially if they're trying to follow that natural route. They're trying to go through and do the selection. And one of the things in there, this goes back to the uncapping aspect. Current methodology is, oh, well, you can freeze or kill a patch of brood and see if the bees will come in and remove it and how quickly they do that. But again, that only tells you that they have a hygienic trait. It doesn't necessarily tell you that they are keyed into the smell of that mite underneath the capping and know that there's a problem there. They're responding to dead brood as opposed to Varroa. So there's lots of little aspects. It's definitely not a one and done easy thing to go out there and do that. And what some people find is they select and breed for this hygienic trait that they're seeing when they do these tests, but they're not actually understanding what that hygienic trait is and what that equates to. And you may end up breeding a line of bees that doesn't really have the qualities you wanted, but you associated them with that because of what you saw them doing, but you had the wrong kind of correlation of those cause and effects to that.
Hygienic doesn't equate Varroa sensitive hygiene, right? So
Right.
it's the two different things. I mean, one is a subset of the other one, granted, but still it's a very specific, specialty in the bees. I love how you talk about detector bees, specialized bees that are really, that's their job to go and do that. And do you think that basically they're not given, so in colonies that have been traded, they're not given the opportunity to develop those traits or to bring them out? And are they, so it's also a question of nature and nurture. Is that something that's been in the genetic pool for eons that's kind of getting reactivated with the need of combating the Varroa mites and their damage, or is that something that they've adapted to and developed over the last few years?
Yeah, I mean, the great observation by John there. And let me just come back to that first, and I'll come back to you, Natalie, with a few thoughts, if you don't mind. I mean, John's point is spot on, isn't it? If you any bee worth its salt, if it finds something, a dead pupa or dead larvae, should know to uncap it. If you times that by 30 or 40 in a little group like that, the smell must be so strong that if a colony doesn't know they've got a problem, then you've got difficult bees, haven't you? Which aren't going to go forward very well. So And I think that's the weakness of those tests, whether they're freeze killed or pin pricked, or on some other things you can spray on at the moment. So we know that bees have this ability to find dead or dying or injured pupae. It's whether they can find the Varroa, which is the key. Is this being bred for? There's people are trying, aren't they? And there's some brilliant work being done in the US. I think we're using the Harbo assay, which we thought about going down that route because it was interesting, but it deals with the end product rather than understanding the full cycle of what's going on between the bee and the Varroa. So and we also felt that you probably need to be a commercial breeder to go down that route, encouraging beekeepers to start opening up cells and sacrificing whole frames of brood towards the end of the season. That's a bit of a no-no at our club. They're all going to be thinking about keeping the brood there for the winter bees, naturally enough. So it's been difficult, I think, and there's been some big work, a lot of work on this by commercial beekeepers to try and find Varroa resistance in Europe as well, and they've not managed it. So the people were looking for a silver bullet, and the failure is difficult to quite pin down. And I think it's partly because it's too complex. So, and I think the USDA have also looked. We're talking about the best funded project in the world here. I've looked for genetic markers for BSH, let's call it that in shorthand. And they haven't managed it, and there's been some European efforts as well which have failed. And I think the reason for this is its complexity. There was a bit of work done out of France in this spring which showed that these VSH traits are polygenic, and they come from different parts of the genome. So there was one example that they analyzed the whole genome of the honeybee and these resistant colonies, and there were 60 different parts of the genome which were contributing to the Varroa resistant traits. Now, putting that into a test tube is pretty difficult to do, and they're nowhere near, I think, achieving it at the moment. But the honeybees have. So how about that? Isn't it great that the honeybees left alone have found the solution? And there must have been, at some point in the millennia during their lifetimes, they must have seen another ectoparasite,
Exactly.
not that dissimilar to Varroa. You've got Tropicalaps out in Asia as well, heading this way. The bees somehow will find a solution, and it will only come initially from being open mated, having this diversity of genetics which they can choose from in effect, and this incredibly high recombination rate of the alleles, again, which is quite hard for beekeepers to get their head around, but it's part of the natural selection process. And all what we have to do as beekeepers is just observe the right trend. We have it simple, really. Now we understand it roughly.
Mm-hmm.
It's a simple task for the beekeepers, but actually for the scientists to pin it down, very, very difficult. And then for the breeders to do the same, it's been pretty much impossible so far.
So is artificial insemination all contraindicated for that purpose? Is that something that would go a little bit, because open mating and extreme polyandry really is helping the bees find those just kind of resurrect whichever genes they're trying to use for fighting those ectoparasites. Is artificial insemination limiting that effort?
It's failed to so far. I think, and there's been an awful lot of money wasted on it as well. So it's been a fascinating fail. And even the ones which have sort of been partly okay, as soon as they open mate, then everything goes wrong. Those traits do not breed true when you force something through the bees, which they don't want, and it's not how they exist. So we have the same problem over here with we have our main government-led body equivalent to the USDA is called the National Bee Unit, and they only believe that this is possible with the controlled mating with drones and with insemination, and it's made them look a rather backward organization, unfortunately. But if we're just putting together some slides, we're speaking at the National Honey Show over here later this month, and we're putting together some slides of all the resistant colonies of at least around 8 years, and also some case studies which were on the website we talked about earlier. And every one of those beekeepers and their bees have open mating. Every one of them. Okay, so it's not necessary. It's just a question of trying to understand the biology of what's going on.
Right.
And I think with artificial insemination and the mass production of bees, if you get it wrong, you're getting it wrong big time. And here's our problem. I suspect you have the same issues with a lot of imports from Hawaii. If they're all mite susceptible bees, then you're just creating a bigger and bigger problem for all those beekeepers. And we have the same issue in the UK. We actually allow imports, okay, which you guys are better under control of, I think. And so we have imports coming in from the Czech Republic, from Italy, from Romania, from Denmark, from Greece, all different types of subspecies, and sometimes mixed strains of them, and they're all pretty much all of them are being artificially inseminated. So they then come to the UK. They're then bred by breeders, or they raise queens and nukes, and then they badge them British and sell them to the beekeepers. And then when they go wrong, those bees, and they're on the phone back to the suppliers saying, well, it got superseded in the first season or didn't last very long. He said, well, probably because of your local bees in the area, you better have another queen, and off you go again. So it's and that's the cycle we're in, isn't it? It's people don't quite understand actually using that locally adapted bee that's used in your environment that suffered the heat effects or the mixed weather we have in the UK is the one that does best. It's so obvious, and it just needs sort of repeating a few times, I think, and that's all we've done. So our bees actually have got darker and darker, which is an indication that they are closer to our native bee. We do have a native bee, Apis mellifera mellifera, which I think was the first bees you had in the US. I think
Yeah, the black bee.
we've had imported bees for 170 years now as well. So there's quite a bit of hybridization going on, but it's very interesting. You just through our project, through our 7 seasons, all of our bees have got darker. So there's a natural benefit to these bees, an actual advantage that they have, and it seems to be coming through. And so next year we're going to try and breed or raise more of these bees with resistance, but also we're going to benchmark what we have to see what level of AMM we have and what the inputs are from other subspecies around Europe. So, and we don't think we can ever have pure AMMs again, because I think the world's moved on, and and it's the same in the US. You've got all sorts of local adaptations all over the place, and you just have to work with what you've got.
So, Steve, something you might find interesting based on that, the AMM, they did a research project in Arkansas in the Southern Ozarks back a couple years ago. And when they went out and found feral colonies of bees and went through and did genetic testing, they found the trace markers from the original black bees that were brought over still
Wow.
in the genetic lines of the bees that are out here today. So they
Wow.
don't look like them. They don't have necessarily a lot of the characteristics, but they still carry that genetic marker from when those bees were here and then interbred with all the different ones that were brought over after the fact. So I found that very fascinating. I was like, holy crap, it's still hanging on in there in the background.
Yeah. Now that is interesting. And it should do. It should, whatever subspecies you brought over should still be there, shouldn't it? And you've got so many different geographies and climates over there that different subspecies may be better suited to different parts of the US.
Well, speaking of which, so it sounds like hyper locally adapted species of survivor stock basically is kind of on the way to the solution. And you were talking in the book about bees that didn't have any defenses or low defenses, basically non-survivors. And you are calling those basically Varroa breeders. is there basically a conflict and contrary efforts getting pulled in one direction or the other? Can we reach that resistance and that tolerance through the locally adapted survivor stock if we keep treating a whole high level? I mean, 90% of beekeepers here treat, right?
Yeah.
And despite that, we still have 2 to 3 times the amount of bees in the wild that are thriving. I guess what I'm saying is, how do we tip the scale to the solution towards the solution, which seems to be locally adapted survivor stock?
Yeah. A lot of education. I
Yeah.
think I listened to a good YouTube speech from Jeff Harris. He was down at Palm Springs, I think, and he's one of his points was, I wish we'd started with the hobbyists because they found it very difficult to turn around the commercial beekeepers who can treat their bees for a few bucks and don't want the economic risk, which I get, you know. But the so from the UK, we have a lot more hobbyist beekeepers here. So we're probably about 60% ish of hobbyists rather than commercial. So, and we've done a huge amount of education so far. It's ongoing. We've probably spoken to about a third of all the beekeeping clubs in the UK. And some of the organizations, the education organizations, the BBK and BIBA are quite supportive. So we're getting plenty of airtime, which is incredibly helpful. What we need to do is to make sure that hobbyists start efforts with their clubs, work together. That's all we've done. It's been straightforward, and we run apiary workshops so that people can come swing by and have had the presentation or read the book and come and see the bees. You know, and it seems hugely impactful for people just to see normal bees doing something that they can look at a picture on a YouTube or a book and they get it. You know, so well, we've got these as well, and most beekeepers do have. If you've used locally adapted bees for a while, you'll see uncapping. You know, it's something that they've actually adapted to. We've had Varroa for about 30 years or so. You know, and in that time, there's either been background adaptation or some inputs from the feral survivors, or there's been some level of adaptation just ongoing, which we just haven't understood. So we used to, 10 years ago, we used to call bulb brood a sort of disease which no one knew nothing about, you know, but it was just highlighted as a bit of a problem, you know. So it was part of the things that beekeepers had to worry about. Actually, it wasn't, you know, it was part of the solution going on right in front of us. We just didn't understand. But we had
Yeah.
a far better idea now. So um, we have to encourage commercial beekeepers. So I talk to them a bit who are raising these bees, and I talk to them about producing bees with Varroa resistant traits. And if they don't, you know, at some point, no one's going to buy these other bees. So there's a bit of carrot and stick here. There's a
Yeah.
great opportunity for the first commercial beekeeper who starts raising this stock.
Exactly.
And we're working on that quietly behind the scenes. And at the same time, we need to encourage the people who are importing to do the same. That's quite hard. And I was quite encouraged last year by we had Randy Oliver at the National Honey Show talking a little bit about his project. And I think only good can come of that because he's the highest profile beekeeper in the world. If he makes some level of success of that, he should be able to encourage commercial beekeepers to start sending in better quality queens into the US.
Well, I think that some of the race people are starting to turn to who's going to be the first few ones that are selling those bees that are resilient and make a premium for it, right?
Yeah.
So as long as the narrative, it's always follow the money, right? And as long as they see the financial incentive to do that, I think they will go down that road, and showing them the trade-off is probably helpful as well.
Yeah, and you've got there's a map I saw the other day about different beekeepers all around the US selling very resistant stock. So I think all the work you've done with the USDA has done has actually spawned an interesting new breeding industry, if you like, and which is really encouraging. But I think it's ever so simple. When you start monitoring, there's some of your stocks are hopeless. You know, if you do proper monitoring, you'll see the difference. And some of them are absolute sinners. You know, they produce so many mites with
Hmm.
associated amounts of deformed wing virus. And in the past, we would have done everything to have kept that colony going. We've thrown everything at it, killed the drones, we'd have formic acid, anything, and then we would have bred from it again if we'd been successful. And you think, gosh, that is just a shocking cycle to be in. So as soon as you start monitoring, you see the difference, and off you go. And if you're getting rid of the worst, the mite breeders, the Varroa breeders, as we call them, if you're getting rid of those, and you're getting, and their drones aren't flying, you're not increasing from them. The ones that you are increasing from, you're in the right cycle. So there's two cycles here. The red cycle we've been in for far too long, which is
Hmm.
we don't know how to select for Varroa resistance. We therefore have mite susceptible bees. You need to treat them to keep alive. Once you've kept them alive, you're thrilled to bits, and then you start breeding from them and increasing from them, making splits. Their drones are flying, and then the other part of that red cycle are the mites. So you never kill all the mites. Doesn't matter how much miticide treatments you put in, there's going to be 5, 10, 20% still alive, and they are the tough survivor stock. So you are selecting for really resilient mites and at the same time breeding from weak bees. I mean, what a cycle to be in. And we've seen it in the UK. So you've got a situation where when Varroacides were first being used, just used one. In the end of the 90s, one set of strips used to go in. And now beekeepers are having to throw all sorts of full nuclear attack on it, just to keep their colonies alive. And that's the end of this process of the weaker bees and stronger mites. But as soon as you start selecting, this is the green cycle, as soon as you start selecting for a Varroa trait, all of that changes. And you end up with a low level of mites. You get that equilibrium, which the parasite is happy with. They've not come here to sort of mow over all the colonies because there's no future for them. So that's what we're trying to get people to sort of understand. We're trying to keep clear a little bit of the people being treaters or non-treaters, because everyone just retreats to their corner and starts throwing stones at each other, and that just gets a bit ugly. And if you talk to someone and say, well, do you have these row resistant traits in your colony? People go, well, I do actually, but I do treat. I thought, okay, and you get people thinking about it and learning about the whole process. And I think that's where the understanding the biology, and it's pretty simple biology that's going on behind Varroa resistance, should get a lot of traction.
That's a great analogy, actually. The whole, if you call them out, they're just going to separate to their corners and everybody's going to hunker
Hmm.
down and they're going to get uber defensive. So I'm going to transition here real quick over. We're gonna carry over some of these other questions to the other segment on Patreon. But one of the themes that we've been asking everybody for our guests here from the United States this season is something that I'm kind of curious what your perspective being in the United Kingdom, what it looks like for you guys. So it's kind of a two-part question. One, how do you currently feel about the state of beekeeping today? Do you feel like things are progressing, they're getting better, getting worse? And then two, do you feel that where you guys are, that you need more people to get involved, that you still need new beekeepers coming into it, or do you feel like you guys are oversaturated with beekeeping out there?
I think we have about the right number of colonies. There's been huge growth and interest over the last 20 years or so, and what we're looking for is a wider understanding of the role of the honeybee in nature. So it can't just all be about honeybees because we love them and are fascinated by them. We have 270 types of bee in this country. And then there are flies and other things which depend on nectar and pollen. So one of the things we preach at the club is just to be cognizant of that. So don't have over concentrations of honeybees in your apiaries. Just think about the balance of nature. So I think, and that's a bit of a sort of turnaround from the commercialization, if you like, and industrialization of the honeybee. That it's actually part of nature, but it is only a part of nature. And whilst we could have more commercial beekeepers and more pollination going on, it's not quite the same level of opportunities that you see in the US. So it's a different environment. So pollination is a lot more restricted. There's some migration that goes on to certain types of blossoms like heather honey or oilseed rape, which is canola, I think you call it in the US, but not to the same extent. And then we have this a lower level of commercial beekeepers as a percentage of the total beekeepers over here. So you can talk a slightly different, have a different discussion, John, with them about the balance of nature. And I know our beekeepers are very comfortable with that, and they're just as interested in, they're fascinated by their honeybees and want them to do well and be healthy, but they also enjoy seeing the butterflies, the hoverflies, the hornets, the everything else around the gardens and out in the fields as well. So that's part of a broader education, which has sort of happened also from the beekeeping community. It's come out of some of the industry magazines, which I think is really encouraging.
I agree. That's one of the things that I have pivoted whenever I'm asked to go and do a talk about bees. I talk just about equally as much about all of the other native bees that are out there besides the honeybee. And then I very discouragingly towards the end of it tell them that we don't need them to be a beekeeper. I don't need everybody in the room to go
Right.
get a hive. I need you guys to plant more native wildflowers. I need you guys to create habitats. This is what you can truly do to help the
Yeah,
honeybee and all the other bees. So it's really kind of interesting to see the different responses. A lot of times, if somebody has a business that is focused around beekeeping, the response
sure,
might be a little bit skewed.
sure, sure.
And when you have people that are doing research about beekeeping, the response will be in the other direction. So I was just
Mhm.
kind of curious what it looked like over there in England and the United Kingdom. You know, kind of how that goes. I have some other questions about your commercial aspect. You actually touched on it a little bit.
Okay.
And we'll carry that over into Patreon. Natalie's got some additional questions. We're going to go a little bit more in depth about some of the topics in your book over there as well. So, for anybody listening to us right now, if you want to join us over on Patreon, you can hear the follow up to the rest of this conversation. But we are going to give you an opportunity, Steve, to let everybody know if they're interested in getting the book, where can they find it? And go ahead and give them that web address again on your guys' research that you put out there a few years back.
Yeah. So the book, the honeybee solution to Varroa, is, if you Google it, it's available from all sorts, including Amazon. But the publisher is Northern Bee Books, and I think they do have a link up with another publisher for distribution in the US and different parts of the world. The website is www.varroaresistant.uk, and it's curated by Professor Stephen Martin, who's, I would say, probably one of the best in the world on Varroa. He's been all around the world looking at Varroa resistant colonies through Cuba and Mexico and Brazil, South Africa, Hawaii,
Hawaii.
yeah, and knows a lot of other people of a similar ilk. So he's been a fantastic resource for us here in the UK, and I think reaches out to other places quite successfully as well. So he's curated all the research on there. So he selects what he thinks is the most pertinent research. I think it's missing a few of the earlier things that we tuned into from the USDA. We thought the work that Marla Spivak did, fantastic hat tip to her and her team, and also Harbo and Harris in particular, just some fantastic work done there, which predates a lot of the things which the Europeans came on a bit later with. So, yeah, the website has got lots of case studies and things on, and whilst they're UK ones, I think they're probably relevant to others as well. There's a few bee farmers. Now, we call a bee farmer someone who can have up to 100 colonies, all right? So it's a different scale altogether. We've got a couple of small bee farmers on there. We've got some people who monitor cavities in large forests and have captured swarms from those, and then can look at them in their managed colonies. So in effect, they're seeing how uh, how bees manage Varroa in those trees, but in their colonies. So there's some great websites, great case studies just to follow through on. So uh, hopefully those are two good sources of information which can contribute to education on Varroa resistance in different parts of the world. I mean, Apis mellifera is pretty much the same in different parts of the world, and one of the things which will probably touch on in Patreon is some of the studies which show that.
Very good. Great segue there for that. Again, anybody else who wants to hear the rest of our conversation with Steve can join us over on Patreon, and that is patreon.com/hivejive. And Patreon is Patreon. .com. So we look forward to seeing you over there. And Steve, thank you again for joining us here on our main segment to talk to everybody about your book and about Varroa sensitive hygienics and traits that we can look at for Varroa resistance. We greatly appreciate it. We look forward to talking to everybody next week. But until then, be good.
And as always, remember to be mindful.
And my French Texan goodbye is Abe, good day.
Abe, good day. I love it.
I'm ashamed.
No, you're good. That was really good.
This Hive Jive production was made possible by amazing patrons like you, and we appreciate your support. To all our Hive Jive junkies out there, you truly are the bee's knees.